This lesson is a continuation of our difference of squares lesson. Reminder for the difference of squares pattern, we have two terms using subtraction where the first term is a perfect square and the second term is a perfect square and they're separated by subtraction. That's how we get the difference of squares name that it comes from, where there's two perfect squares and we are subtracting. So yesterday we talked about just looking at the first two terms. Today we're going to look at if we have to factor something out first, where we have to factor out the greatest common factor between those two terms first. So in this one, looking at the two coefficients, I have a 20 and I have a 125. Deciding what to factor out, 20 and 125 both share a 5. So if I were to divide out a 5, and then looking at our variables, I have a d to the 8th and a d squared. Both are sharing at least a d squared, so I want to factor out a 5d squared from each term. So 20 divided by 5, we have 4. D to the 8th divided by d squared, I would have d to the 6th minus 125 divided by 5. So we have minus 25, d squared divided by d squared, they cancel each other out. So after dividing out that greatest common factor, dividing out a 5d squared from each term, I'm left with 4d to the 6th minus 25. Now I can factor this using difference of squares, because this first term is now a perfect square. 4 is a perfect square, 2 times 2 to get 4. D to the 6th is a perfect square. Because it's an even exponent, I can multiply d cubed times d cubed. And then minus 25, 25 is a perfect square. So yes, this would be a perfect square binomial because they're subtracting two perfect squares. Looking at our next example, I have a 5w squared minus 20. If I factor out what's in common, this one has a 5, this one has a 20. If I divide out that 5, I would be left with w squared minus 20 divided by 5, so minus 4. So checking to see if it's difference of squares. Am I subtracting two perfect squares now? W squared is a perfect square, and 4 is a perfect square, and it's subtraction. So yes, this one is difference of squares pattern. I'm subtracting two perfect squares there. Last example, 8p to the 4th minus 50p squared. So first looking at factoring out what is in common, both 8 and 50 share a 2. So 2 is part of our greatest common factor. And then p to the 4th and p squared, if I pull out what they both share a p squared. You would have, so 8 divided by 2, we would have 4. P to the 4th divided by p squared would be p squared. So 4p squared minus 50 divided by 2 to get 25. And then p squared divided by p squared, those two cancel out, and that would be our answer. So now I'm comparing, is this difference of squares pattern? Am I subtracting two perfect squares? So 4p squared, 4 is a perfect square, and p squared is a perfect square. It's an even exponent. I'm subtracting. And 25 is a perfect square. 5 times 5 is 25. So yes, this one is also difference of squares pattern.